it sends its current, so it'll split it up evenly. All right. Okay. Do we want to try to take a crack at this one, try to combine this one down, and then come back in a few minutes? You can
Yeah,
answer.
sure.
Okay, yeah. I'll stop the recording, and we'll come back in just a bit. All right, so let's take a look here. All right, so this is asking us to find the V of L value. So V of L is going to be here. Now, something to note, in a circuit where there's only one source, we're going to assume all the battery voltage is used up. And that means it's just all these resistors are going to soak up all the voltage from that battery. So that means for us that we're going to be entering to this battery with 0 volts. We'll pass through it, and we'll pick up 12 volts. So we'll end up with 12 volts here, because like we said earlier, the voltage in the wire is the same up until it reaches an element. So 12 volts here, 12 volts there, 12 volts there. We come right here, still haven't hit an element yet, so there's 12 volts here. There's also 12 volts there. But then we hit an element, and then we kind of hit a snag. Well, let's kind of come down here. If we know that there's 0 volts down here, there's 0 volts right there, 0 volts right there. Hit this point, there's no elements yet, so there's also 0 volts here, and also 0 volts here. Okay, so if we kind of just take a look at this part, we can just use that as our problem instead of the entire circuit. So now, if we want to find the voltage across this one point, let's just say we see that this looks like it could be one big wire if we combined these 2 resistors down. So let's do that real quick. We'll call these parallel 1. So R parallel 1 will be equal to 4 times 6 over 4 plus 6, 24 over 10, which will give us 2.4 ohms. Five, 2.4, then 5. 0 volts, 12 volts. So now we're still finding the voltage across that value. So this is still V of L right here. So if this is V of L, and this is one continuous wire, from our concepts, since this is in series, we can use voltage division. Okay, so we can say voltage V of L is going to be equal to a resistor 2.4 over R series times the voltage difference. So here it would be 12 volts. This would be 2.4 over 5 plus 2.4 plus 5, 12 volts. And what does that give us? Uh, 2.32 volts for V of L. All right, and that's the final answer for this specific problem. So we took a big diagram, made it a small diagram, and it was really 3 steps of math. Does everyone see what I did here? Does anyone have any questions about it?
I have a.
Yeah, what's up?
So how does VL not change when you combine it with the resistor in parallel?
Excellent question. So how we said before, how the voltage doesn't change in a wire until it hits an element. So here,
Okay.
I'm just going to call this like V, just capital V, that's fine. Well, here, kind of like how we set up here, 12 volts, 12 volts, 12 volts, 12 volts, even though it passes that junction, but it doesn't hit an element. So right here, that's also V, and right here, that's also V.
Yeah.
So it's going to drop down, but there's some voltage value here as well. V of A, whatever. But right here, it's the same situation, just flipped. So that's also V of A. We haven't hit any elements yet. That's also V of A. So you'll notice that from here to there, from there to there, it's still losing the same amount. So
Okay, I see.
you see what I'm saying
Yeah,
there?
since the voltage is the difference, it's
Yeah,
changing on both of them. Okay.
yeah,
Because I figured since they were different resistors, but yeah, I guess that makes sense.
yeah, and that's kind of it's a very important concept, and I'm very glad you brought that up.
So does that mean that anytime that it's in parallel, the voltage is going to be the same across it?
That is absolutely correct. That is, yes, perfect.
Okay.
Yeah. I'm glad that like you're all piecing this together, because if someone wasn't going to ask it, I was going to come back to it, but no, you guys are doing fantastic. Okay, that's great. So yeah, that's why. So resistors in parallel are going to have the same voltage across them. So yeah. So now let me ask you this: what is the voltage across this resistor?
The same thing,
Yeah,
2.32.
that's right. Absolutely, it's the same thing. So like we said here, if we went from here to there, this resistor, that 2.4 resistor, is just these two combined. So they'll have the same voltage across it. So yes, that's correct. So if we find that voltage, we find it for this one and that one. Very good, very good. Okay, it's 7:16. We have about 4 minutes left. We have 2 problems left. If you want to stay, you can. If not, it's fine. It won't hurt my feelings. So I'm going to finish working these problems out. If you have any questions, of course, just stop me. All right. Here we go. Okay. So this problem is asking us to find the values of